says to go ahead and graph your velocity function. So you draw your axes. Label your axes. We know it's a line, slope of 2, y-intercept of 0. We're graphing only from 0 to 6, so it would look like this here. Now it wants you to go ahead and find your velocity at 1. So you could go over here to 1, and then you could go up to your height, but since our function is 2t, all we have to do is take 1 and plug it in for t right here, and we get 2. Now we got to go to 3. So we go over here 3. If we know our input's 3, we could figure out our height right here, how far up you are at 3 by taking 3 and plugging it in. And we get 2 times 3, which is 6. And then you're asked to figure it out for x. So if you're x units over, what would be your height? Well, if you're x units over, just like all the other ones, all we have to do is take that and plug it into our function. So we'd have then 2 times x. Now, you're asked to go ahead and find the area underneath your curve. Well, as you look at the shape here, it's just a triangle. You know how to find the area of a triangle, so you're going to go 1/2. Your base, which is 6, times your height. Well, let's see, if we're over here 6, to be able to figure out our height, all we have to do is take that and plug it in, 2 times our 6, and we get 12. And then all we have to do is go ahead and multiply that out, and we get 36. And in the context of this problem, it would be distance. So what does the area underneath the curve represent? And it's distance. Because the area underneath the velocity curve is distance, because you'd have units here similar to feet per seconds, times this side here of seconds, feet divided by seconds, multiplied by seconds, the seconds drop. Now it wants a general expression for your area underneath your curve from 0 to b. So you're going from 0 all the way over to b, so that means the height here would be 2b, so that would be your y-coordinate. Your x-coordinate is this. Why is it 2b? Because you take whatever your x is here, plug it into your function, 2 times your input, and you get 2b. Or not to be, that is the question. So we go ahead and we look at our area here. We're going to go 1/2, how far over we are for our base, which is b, times our height here, which is 2b. And we multiply your half undoes your 2, and you get b squared. So in other words, it's saying no matter how far you are over here, your area here is just going to be that number squared. And that's what we noticed up here. When you were 6 over, our area was 6 squared, or 36. Now, looking down here at 109, you're asked to go ahead and look at your distance function. We have our distance function over here. We're only graphing it from 0 to 6. We have our labels and our units. And our graph looks pretty much like this here. Just half of a parabola is all that we're seeing. Then it asks you to go ahead and find the slope of your tangent line. Well, the slope of your tangent line, remember, is your Iroc formula. So we got to do the Iroc formula on our t squared. So we'll have to go limit h plus, or t plus h all squared minus our original function all over h. FOIL out the top here. Our t squareds drop. Notice everything then has an h in it. You can take that out. Then we can go ahead and plug in 0 for our h. And then we get 2t. So we get our distance function, or not the distance function. The distance function is t squared, but the slope of our tangent line is 2t. That's our derivative. We want to know our derivative at 1. So we got to take 1 and plug it in here. So it'd be 2 times 1, which is just 2. Then we got to take 3 and plug it into the slope of our tangent line, which is our derivative function right here. So it'd go 2 times our 3, plugging it in right here, and we multiply and we get 6. Now it says we got to go ahead and plug in x. So we got to go 2 times x, and we get 2x. So it says all we have to do is to go ahead and find out what this is at different spots. Now, as you look at your slope here, remember slope is rise over run. So it's going to be the change in our feet over the change in our seconds. So feet over seconds. So all these here are representing our velocity because it's velocity because that's the units of feet over seconds. Feet per second is velocity. So at 1 second here, our velocity is 2 feet per second. At 3 here, the slope of our tangent line, which is also our velocity, is 6 feet per second. At anywhere along here, it is 2 times x for our feet per second. Then it wants down here to find the total distance underneath your curve. Or not the total distance under your curve, sorry, the total distance. So we have to go up to our distance function and plug in our 6. 6 squared is 36. So our distance for the first 6 seconds is 36. So now it wants to know what is our relationship between this problem and the previous problem. Well, the area underneath your velocity curve is distance. So the area underneath our velocity curve is 2t for the first 6 seconds was 36. Or, as we figured out before, the area underneath our velocity curve of 2t for any time was our time squared. So our distance was time squared. And that's what we noticed right here when we said the area anywhere along was b squared. So we also need to consider that the slope of your distance function, which we said was your velocity, so the slope of your distance function, which is your slope, your instantaneous rate of change, which in this case, since it's the instantaneous rate of change of a distance function, is velocity. Your slope, your velocity anywhere along this function, as we figured out right here, was 2 times your input, 2t.